Hello everyone, myself G. Chandana, graduating from Srinivas Ramanujan Institute of Technology. Today my topic in this presentation is verification of Green's theorem, followed with an example from the subject differential equation and vector calculus. Next, Green's theorem in a plane. Green's theorem is relation between the line integral and the double integral. If R is a closed region in xy plane bounded by a simple closed curve C, if m and n are continuous functions of x, then x and y having the continuous derivatives in R, then we have the formula integral m dx plus n dy is equals to double integral of dou n by dou x minus dou m by dou y into dx dy, where c is the transverse in the positive direction, that is anti-clockwise direction. Here we have a question. Verify Green's theorem in a plane for integral x square minus xy cube into dx plus y square minus 2xy into dy, where C is a square with vertices 0, 0, 2, 0, 2, 2, 0, 2. So here they give a plane and also give the vertices of the square. Next, coming to the solution. They gave the line integral x square minus xy cube dx plus y square minus 2xy into dx. We will treat this equation as equation 1, and the vertices of this square, let us assume these points as O, A, B, C. Here is a graph uh, from the equation 1. It is in the form of integral m dx plus n dy. So we will treat m is equals to x square minus xy cube and n is equals to y square minus 2xy. If we differentiate m with respect to y and n with respect to x, now dou m by dou y is equals to x square becomes 0 and xy cube becomes x into 3y square, that is minus 3xy square. Now dou n by dou y, y square becomes 0. If we differentiate minus 2xy, x will be 1, so minus 2y. So dou n by dou y is equals to minus 2y. Next. From the Green's theorem, we have this formula. So now we have to verify LHS is equals to RHS. Now let us calculate the LHS. Here the curve is a square boundaries of sides OA, AB, BC and CO. Now integral m dx plus n dy is equals to integral OA plus integral AB plus integral BC plus integral CD. So now we have to calculate all these curves. So let us consider this equation as equation 2. Here we will solve along OA. In the graph, we have the points O and the A. O is at 0, 0 and A is at 2, 0. Here X points are changing from 0 to 2 and Y are constant, that is Y is equals to 0. So here that is X is equals to 0 to X is equals to 2 and we have Y is equals to 0. If we differentiate Y, dy by dy is equals to 0 and also dy is equals to 0. Now integral uh, OM m dx plus n dy is equals to, this is the given equation from integral 0 to 2 x square minus xy cube into dx plus y square minus 2xy into dy. Here we have y is equals to 0, so we will substitute y is equals to 0 here and here. So it will, and also dy is equals to 0. So total this term becomes to 0. So that is integral 0 to 2 x square minus, here we'll place 0. So that will become x into 0 power 3 dx. So whole term becomes 0. Then we have integral 0 to 2 x square dx. If we integrate x square, we have the formula integral x power n dx is equals to x power n plus 1 by n plus 1. So we have in the place of n we have 2. So x power 2 plus 1 by 2 plus 2. So we'll get x power 3 by 3 from 0 to 2. For this also we have formula x from a to b is equals to b minus a. So in the place of b we have 2 and in place of a we have 0. So first we have to substitute 2 in place of x and then uh, 0 in place of x, that is 2 cube by 3 minus 0 by 3, that is equals to 8 by 3. Next, AB, A is point at 2 comma 0 and B is the point at 2 comma 2. Here x is constant and y is changing from 0 to 2. So x is equals to 0 and dx is equals to 0. Integral AB m dx plus n dy is equals to integral 0 to 2 x square minus xy cube into dx plus y square minus 2xy into dy. Here dx is equals to 0, so this whole term becomes 0 and we have to replace x is equals to 2 here. So that will become integral 0 to 2 0 plus y square minus 2 into 2y into dy, that is equals to integral 0 to 2 y square minus 4y into dy. If we integrate this, that will become y power 2 plus 1 by 2 plus 1 minus 4 into y power 1 plus 1 by 1 plus 1 from the intervals 0 to 2, that is y cube by 3 minus 4 into y square by 2 from the interval 0 to 2. Here we will cancel 2 ones are 2 twos are, that will become y cube by 3 minus 2y square from the interval 0 to 2. Now we have to substitute 2 and then minus 0, that will be equals to 2 cube by 3 minus 2 into 2 square minus if we substitute 0 in the in place of y, that will become 0 minus 0, that is equals to 8 by 3 minus 8. If we add this, that will become minus 16 by 3. Next, B is pointed 2 comma 2 and C is point at 0 comma 2. If we see in the graph, that is x is changing from 2 to 0 and y is constant, that is y is equals to 2 and dy is equals to 0. Now integral BC m dx plus n dy is equals to integral 2 to 0 x square minus xy cube into dx plus y square minus 2xy into dy. Now we have here dy is equals to 0, so this whole term becomes 0, that is integral x square minus x into, we have to substitute y is equals to 2, so that will be y cube into dx, that is integral 2 to 0 x square minus 8x into dx. If we integrate this, that will become x y cube by 3 minus 8 into x square by 2. We have cancelled 2 ones are 2 4 are. So the intervals will be 2 to 0. We have to first we have to substitute 0 in place of x and then minus we have to substitute 2 in place of x, that will be 0 minus 4 into 0 minus here 2 into 2 power 3 by 3 minus 4 into 2 square, that will be here this whole term becomes 0 minus 8 by 3 minus 16. If we make LCM, that will become 40 by 3. Now along CO, if we see the graph, C is pointed 0 comma 2 and O is the pointed 0 comma 0. So here y is changing from 2 to 0 and x is constant, that is 0. So dx is equals to 0. Now integral CO m dx plus n dy is equals to integral 2 to 0 x square minus xy cube into dx plus y square minus 2xy into dy. So we have dx is equals to 0. So this whole term becomes 0 plus y square minus 2 into this here we'll replace x is equals to 0. So this whole term becomes 0. Then we'll get integral 2 to 0 y square dy. If we integrate this, then we'll get y cube by 3 from 2 to 0. First we'll substitute 0 minus then 2 in place of y. That will be 0 minus 2 cube by 3, that is equals to minus 8 by 3. Now we have to substitute all those values in the equation 2, that is integral m dx plus n dy is equals to integral OA plus integral EB plus integral BC plus 0. So we got the values, that is and integral OA is 8 by 3 and AB is minus 16 by 3 and BC is 40 by 3 and CY is minus 8 by 3. So 8 plus 8 by 3 minus 8 by 3 will be cancelled. If you make LCM, that will be minus 16 plus 40 by 3, that is 24 by 3. 3 ones are 3 eights are, so the answer will be 8. Now let us check the RHS, that is double integral of dou m by dou x minus dou m by dou y into dx dy. Now we have the points at x is equals to 0 to 2 and y is equals to 0 to 2. We already calculated dou n by dou x minus dou m by dou y, that is minus 2y plus 3xy square into dx into dy. Now we'll integrate, first we'll integrate this term with respect to y and next we'll integrate with respect to x. Here integrate y is equals to 0 to 2 minus 2y plus 3y square dx will be minus 2y square by 2 plus 3y cube x into y cube by 3. 3 cancel, 2 cancel from intervals 0 to 2. First we have to substitute 2 and then 0, that will be integral 0 to 2 minus 2 cube plus x into 2 cube minus 0 into dx. Now we will integrate these terms with respect to x. Integral 0 to 2, it will be minus 4 plus 8x into dx. Integral 4x will be integral 4 will be minus 4x and the 8 will be 8 into x square by 2 from the intervals 0 to 2. So that will be 4 into 2 plus 4 into 2 square minus 0. So that will be minus 8 plus 16, that is equals to 8. LHS we got 8 and also got 8 in the RHS. So LHS is equals to RHS. Hence the Green's theorem is verified. Thank you for watching this video.